Like Miss Jackson said, today we are talking about standard form and vertex form. We've already been working with equations in standard form, you just didn't know it. Standard form is a way that we can write quadratics where we can also run what's called a regression. I almost said that funny. What do y'all notice about this that I'm highlighting? What do you notice about it?
Squiggly line.
It's got the squiggly line. What else had the squiggly line that we had been working on? Yeah, so we had a linear equation, y1 squiggly line mx1 plus b. We had an exponential equation, y1 squiggly line a b to the x1 power. This is, you don't have to write that down. This is the quadratic version. It's called standard form. That you do write down. Standard form. Because most equations that we get that are quadratics are going to be written like this. This is kind of like those polynomials that we spent a long time factoring. Doing the x puzzle, getting a, b, and c, and writing them in factored form with the two parentheses. But what we're going to be able to do today is use technology, use Desmos or use the calculator, but we're going to use Desmos because it's a little bit easier, and you have it at home to practice with, to write a regression. So what's going to happen is you're going to see a table like on these two examples. And some of y'all did this last week. Some of y'all told me this when we saw tables last week. You're like, oh, just put it into Desmos. But I was like, great, amazing, love it. Next time. So today, when we see a table, we're going to follow the steps up here on where it says process. You're going to add the table. You're going to type in the table. You have to type every point they give you. Can you just pick a couple of them? No. You need to type every point in. And then, take your pencil right now, put little stars next to this equation right here. You have to remember this. But this is just the fancy version of equation number 12 on your formula chart. Look at equation number 12 on your formula chart. It says quadratic standard form. Yes, it says f of x instead of y, but you know those are the same things. And so you can just take that number 12 equation and make it fancy. When you finish typing in y1 squiggly line a x1 squared plus b x1 plus c, takes a lot of typing, you're going to get a, b, and c on your parameters. And then you just plug in the a where a goes, the b where b goes, and the c where c goes. And that's it. Can we try a problem? Are we here today? Can we try a problem? Okay, number 1. It says, after a break, 2 students came to school with the flu. The table shows the total number of students infected with the flu X days after the break. The data can be modeled by a quadratic function. This telling us it can be modeled by a quadratic function is our key to knowing what to do here. What are we going to do with this table? All right, I'll give you a second to get it typed in. Yes, you have to type the entire table. Every single point needs to be there. And now that we've typed it all into Desmos and done y1 squiggly line ax1 squared plus bx1 plus c, the mouthful, you're going to go ahead and write y equal to, and then tell me the a, b, and c values. What was the a value on your screen? 0.025? Yeah, we're just going to round it to 3 decimals. We're just going to truncate it. X squared, and then minus 0.1, thank you, 37 x, and then plus 1.958. Do you see how those numbers, the a, the b, and the c, came from exactly Desmos, putting them in then in a, b, and c. I just rounded because they're really long numbers. You could write as many numbers right there as you want. It doesn't say how much to round by. But the reason that we have these equations is because having a prediction line or curve that allows us to predict the future means we're going to be able to answer this next question. It says, predict how many students will be infected after 60 days. So question. If they said after 60 days, did they give me an input value or an output value?
Input.
They gave me an input. Very good. What letter is the input value always? Is it X or Y? So we have an equation of X equal to 60 that we need to also graph at the same time. So underneath your equation, don't delete anything because we're going to use that prediction line to figure out how many students will be infected after 60 days. So again, because that point of intersection is at 60, 85 point something, that means that the number of students that will be infected after 60 days is going to be about 85 students.
Russia versus Ukraine.
This one, and we've talked about how we got the input numbers, the A, B, and C numbers for the equation, and got the input and the output for my prediction. You guys are going to try this example too. So there's the equation that we got. Again, I didn't tell you how to round, so you could have rounded in any way because I didn't specify. But if we want to predict the distance of a ball hit at an angle of 44 degrees, did they give me an input or an output? Input. They gave me an angle measurement, and my angle measurement is my x value when my output is the distance. So I also want to graph the line x equal to 44 and see where it crosses. It should have crossed at the coordinate point 44, 303.962-ish. Is that what y'all saw?
Yeah.
Which means the distance of the ball would be 303-ish, I guess round up, 303.96 feet. 303.4. What if you put what? That's the same. Yeah, that's just round. There's not going to be, I'm not going to take off for rounding because it doesn't really matter. You're going to be looking at answer choices and picking the correct one. They're not going to be rounding error differences. So I'm not going to take off for rounding incorrectly or differently than me because I didn't specify how to round. Okay, so that's taking an equation, taking a table and writing an equation. Just like we did for linear, exponential, now quadratics also has a regression. A line that we can use to create the equation and then predict the future. This is the third time we've done this sort of skill. It's the third type of equation, but the third time we've done this skill. Let's move on to the back, please. The next form of an equation that we're going to talk about is called vertex form. Now it's called vertex form, and it's on your formula chart. It's number 13 on your formula chart. It's called vertex form because it gives us a lot of important information, including the vertex. Vertex form can be used to represent a quadratic function whenever its vertex and another point on the graph are known. What is the vertex? Like, where is that vocabulary word located on a graph? The bottom or the top, right? It's the turning point of the graph. In this vertex form, we've got a bunch of letters here. We've got A, we've got X, we've got H, we've got K, and we have Y. We have all of these letters that we're going to be using in vertex form. The letters H and K are the vertex. So circle these two letters right here. I need you to know that H, K is the vertex. That's super important. We also are going to be plugging in a coordinate value, X, Y. That's any point that the parabola also passes through, which means what letter am I missing? A. I'm missing the A value. That means that we're going to have to set up an equation and solve for A. Now, this is really good practice for us on just regular solving equations. This process, especially when you don't have answer choices to check, is a good way to practice our solving equation skills. So that's what we're going to do. We're going to write the equation of a quadratic with a vertex at 3, -4 that passes through the coordinate point of 5, -12. Which means that H is 3 and K is -4. It also means that X is 5 and Y is -12. Do you see how I'm just literally taking those coordinate points and giving them letters? H, K is the vertex, X, Y is the coordinate point. We're going to plug those numbers in to the vertex form equation. So the first letter, it says y equals. What number is y? Negative 12. Okay, we put a negative 12 right there. All right, then we have equals a. Did we have a number for a? No, so we're going to leave it as a. Did we have a number for x?
Yes, 5.
5. And we're going to subtract h. What was the number for h?
3.
Okay, and then we're going to square that, and then we're going to add k. What was k?
4.
Negative 4. All right, great. So I've plugged in everything I know to this equation. How many letters are left?
1.
Just one letter, just the a. If it's a single equation, single variable equation, we can solve. We just have to remember our Pemdas and then our solving equations rule. What does Pemdas tell me to deal with first when I'm simplifying an expression? Parentheses. Can I reduce that parenthesis?
Yes.
Yeah, what is 5 minus 3? Don't overthink it. 2. Okay, so then I have a 2 in that parentheses. What else does Pemdas tell me to deal with next?
Multiplication.
Ooh, P-E-M-D-A-S. What's the E?
Exponents.
Exponents. I have exponents, so I got to deal with them. What is 2 squared? Yeah, you do.
2 squared is like 4.
4. 2 times 2, which is 2 squared, is 4. Okay, I have no more simplifying to do. I just have solving. We're going to solve this because, remember, we're solving for this letter A. We're going to solve this like it's a regular equation. Those of you who did the box method, I'm not using the box method here. I'm using inverse operations. What's the inverse of subtracting 4? Okay, so I'm going to add 4 to both sides. And because those are like terms, I can actually combine them. Negative 12 plus 4 is negative 8. How do I get that a by itself? Ooh. I divide. It is currently multiplied, so to undo it, I would divide. Which means, what's the value of a? What? This will cancel out to 1. But what's negative 8 divided by 4?
2.
Negative 2. Very good. Okay. So now I have a value for a. The very last step here after solving that equation that I wrote myself to set this up is to write our final answer back in vertex form. I need you to write this down. The only 3 letters that you're plugging back in the final step are A, H, and K. Ach, if you will. A, H, and K. Okay, so I keep Y. Y equals A times X minus H squared plus K. And voila, I have written a vertex form equation that passes through that vertex, or has that vertex and passes through that point. Before you flip this over, though, we need to check our work. We need to make sure that this is right because there's no reason why I can't check this. So how you check this problem, what you're going to do right now, absolutely Desmos. What do you think we're going to plug into Desmos to check?
No, why?
Do we have a table? We could do a table, but it's easier a different way. We're going to take this equation and we're going to type it in. And we're just going to check to see if it has an actual vertex at that point and goes through this coordinate point, the information that we started with. So everybody right now, type in the answer that we ended with. And I want you to see if it has the correct vertex and passes through the correct point. You might have to type the point in, like parentheses 5, comma, negative 12 parentheses, just to see if it goes through that point. So we're going to do 2 examples exactly like this, where we have to find the a value and then write the vertex form equation. So y'all are going to walk me through this first one. Let's go with Niante. It says the vertex is at negative 3, comma 2. Which 2 letters is that?
Vertex form.
This right here. What 2 letters is that?
Those are
H and K. Thank you. Okay, sorry, you just answered a question. Kylan, what is these equations, or this, what words are coming out of my mouth? What is this coordinate point? What letters?
X and Y.
Very cool. All right, so we know that H is negative 3. We know that K is 2. We know that X is negative 1. And we know that Y is 14. Fabulous. I'm just going to fill in equation number 13 on my formula chart, so you should be able to look at it. It starts with f of x, which is the same thing as y. So we're going to have y equal to a. I don't know a, so I'm going to leave a like that. Then I have an open parenthesis, and I have the number x. Then I'm going to subtract. What letter? What came next? H. Very good. So minus 3. Close parentheses squared. And then plus k. Yuck, I got a minus in there. AB, what happens when you have minus a minus? You add them together. It's like a big plus sign. Okay, cool. That looks a lot easier for my brain to start doing PEMDAS. Malik, we're going to start off with PEMDAS. So we're going to do 1 plus 3 squared. What is negative 1 plus 3? Negative 1 plus 3 is 2. And then 2 squared is what? 4. So I have 14 equal to 4a plus 2, right? I did minus 1 plus 3. That's 2. We squared that. That's 4. Thank you. The next thing I'm going to do is to do what? Does anyone remember the next step? All right, Robert, what are we doing? Subtract 2 from both sides. Very good. That means that we're going to have 12 equal to 4a. Yannick, what's the very last step here? Divide, and what am I dividing by? 4. Which means we're going to have 3. Yeah, a is equal to 3. Fabulous. Okay. Kilo, what 3 letters do I plug in at the very end? A, H, and K. Fabulous. So I'm going to leave y equals. I need a, which is 3. And then leave x, but I'm going to subtract negative 3 square and then plus k, which is 2. And just before I finish this up, just to clean it up a little bit, I've got that minus a minus. What happens there? That's a big add sign. Okay, cool. And fabulous. That is the vertex form that passes through the coordinate point negative 1, 14 with the vertex at negative 3, 2. But don't take my word for it. Let's double check and make sure we got this right. I'm human. I make mistakes. Go ahead and type this into Desmos and ensure that it has the correct vertex and it goes through that point. All right, we're going to work our way through the next example, just kind of the same way we worked through this one. Thank you for those of you who are following instructions. It says, write the quadratic function in vertex form that has a vertex at negative 5, negative 3 and passes through the point negative 8, negative 15. So Maya, what letters did they give us for negative 5, negative 3? H and K. So that means H is negative 5 and K is negative 3. All right, Tristan, since you want to answer the next one, what's up? All right, so X is what?
X is
Negative 8. And Y is? Fabulous. Okay, now we want to plug this in for everything we know. Well, the only letter we don't know is A, so everything else should be written in. We're going to have negative 15 equals A, which we don't know, times negative 8 minus negative 5, which, yes, will eventually change to plus 5. Very good. Actually, I'll just go ahead and change it to a plus 5 since you already pointed it out. And then we're going to add K, which is adding a negative number, which is just subtracting. But there, I've plugged everything in. We go ahead and we do PEMDAS. I'll show an extra step of work here for you. This is going to be negative 15 equal to A times negative 8 plus 5. That's negative 3. Negative 3 squared is negative 3 times negative 3. What's negative times negative?
Positive.
Positive. So this is positive 9A minus 3. I know I just blew through that kind of fast, but Delaney, what's the next step here? Hold on, Delaney's going to answer. Yeah, so we're going to add 3 since that's its inverse operation. And we're going to get negative 12 equal to 9A. And now, class, what do? Divide by 9, divide by 9. Now, that doesn't actually divide evenly, so we're going to get a fraction here. No big deal. We can have fractions. This is going to be the fraction negative 4 over 3 equal to A. And again, no big deal because all we're doing is taking that A value and plugging it into my equation. Yes, sir. So we write our final answer as y equal to A times x minus negative 5, which I know y'all are already going to tell me to change that to a plus because it's minus a minus, plus k. And we have our vertex form equation. But again, we know we're going to get this problem right because we can check visually to make sure it has that correct vertex and goes through the correct point. This is another one of those questions that if you miss it, that's ridiculous. You have to get this question right. There's no reason, especially on a multiple choice test, that you get this question wrong. You can look at it and see if it has the right equation by going through the vertex and the point. It's kind of like an equivalent question. Like, you should get this one right. Okay, the last little bit of our notes today is going to be similar to what your homework looks like. So it says, on problems 5 and 6, both of them are asking the same thing. However, what? However, this time you're given answer choices. When you have answer choices, what can you do with them?
Put it this way.
Put it in Desmos. Okay, everybody put answer choice A into Desmos right now. I want to see what answer choice A looks like so that I can give you all of this information about it.
So this is not homework.
All right, so you've got that typed in. First question. What's the vertex of your graph? What's the vertex of your graph that you just graphed?
The vertex.
5,2. Thank you. Okay, look at the questions here. Question A, exercise A, says to write in a quadratic function in standard form that has a vertex at 5,2. Number 6 says write a quadratic function in standard form that has a vertex at negative 2,7. Is that what we got? No, so which question does answer choice A go to? Number 5. So we're going to put A right here for vertex form. Now my next question for you is to make this make sense to you. Look at the A value in this vertex form. What's the A value of that vertex form? Negative 3. What other equation up there has the same A value? That's going to be partnered with it because the A value is the same for both vertex form, standard form, and what we learn as factored form. That A value should be the same. It's the same letter. ax squared plus bx plus c, or ax minus h squared plus k. That a is there both times, which means that number 6 right here is which vertex form answer choice? Oh, what's the difference though? Which one is written in vertex form, B or D?
B.
B is written in vertex form. The one with the parentheses, the one set of parentheses is vertex form. All right. Plus, like, look, these A values match, so we know these have to go together because it's the same A value. All right, after this, it's just a vocabulary review. You have that first graph typed into your Desmos. Where does it cross the x-axis? Ooh, let's back up. How many times does it cross the x-axis? 2 times. What are the values where it crosses the x-axis? 4.1, comma 0, and what else? 5.8, comma 0. Those are the 2 places where this crosses the x-axis. You can just round for me. Yes, sir. Yes, sir. Which means if those are the x-intercepts, that means my zeros are at 4.1 and at 5.8. Because those are the same thing. The x-intercepts and the zeros are the same place on this graph. You might have to scroll around for this, but where's the y-intercept? Yeah, you have to scroll a little bit. On a little scavenger hunt to find it. Yeah, 0, comma negative 73. Very nice. That is the y-intercept. Let's skip axis of symmetry for a second. What's the vertex? We already answered this question. It's in the question itself. What's the vertex? 5,2. Does this graph have a maximum or a minimum? And what is the highest that it goes? 2. The axis of symmetry is in the middle of the vertex. We already used the number 2 from a maximum value. So what number am I going to use in axis of symmetry? But is it x equal or y equal 5?
X.
Always x equal. Fabulous. Now, does this graph ever stop on the left? Does it ever stop on the right?
No.
What is the domain?
All real numbers.
Fabulous. And then the range. I just need to know the range of this graph. You told me it had a highest point at 2. If that's the highest it goes, do I want to use the left-handed symbol or the right-handed symbol? Right-handed means bigger.
What?
We want less than or equal to, because the whole graph, the curve is below 2, so it's less than 2. So everybody finish example 6 now that we've got that one done, please. We're answering questions about the next one. We know it's vertex form, what is happening? B and D, and it doesn't matter, again, which one you put in. They're equivalent forms. They should be the same thing. What's happening on your graph for the x-intercept? They don't have any. So you're going to put none or the phrase, no, let me use the right color, no real solutions.
Can I remember that as no man's land?
Sure, or you could just say none.
Okay.
But on a test or something, the mathematical way to say it is no real solutions or no real zeros. But none is fine. N-O-N-E, none. But where is its y-intercept? It did have a y-intercept. Where was it? 0, 19. Its vertex, we already know, is at -2, 7. Does this have a maximum or a minimum? Minimum. And how low does it go? 7. Now that means its axis of symmetry is x equal to what? -2. It should be the other number in your vertex. Its domain never stops, so its domain is all real numbers. And its range is all numbers that are larger than 7, since 7 is its lowest value. And bigger is the right-handed symbol. Yes, sir. Oh, I thought you were raising your hand.